Well, I couldn't resist. It's been 2 years since starting the project and I still haven't been able to walk on a planet. So I gave in. I've been able to dedicate a full working down to Dom, so I decided to start doing a prototype Planetary renderer. And I thought a little video dev diary would be a good idea as an insight into the process, warts and all. So I've had the basic approach for this in my head for years. It's based on a cube of all things, which then gets deformed into a sphere when rendered. For those of you who've engineered this kind of thing before, don't laugh, this is experimental prototype stuff. There are lots of things to be done and I doubt I'll get this as good as the others you can find on YouTube. Here's the basic starting point then. Nothing exciting, just a 6-sided cube split into grids, each is then pushed out to form a sphere. Think of it as kind of inflating a cube. So when you get closer we fly into more detail. This is all CPU side at the moment and it will probably move to GPU when I get the mechanics nailed down later on, especially when procedural terrain gets involved. Here you can see a pinch point caused by the spherical deformation of the cube's grids, although it's noticeable in wireframe. When it's height mapped and textured you won't notice it so much. As we drop the detail down you can see the basic object is indeed a lowly cube. Oh, whoops, I don't know how that got there. Next. Right, so now we're getting into it. Rather than dev and debug the entire sphere, for now we'll be working with the top section only, just to get all the basic algorithms in place. This is the first pass of dynamic patching. As the camera nears the patch, it tessellates to increase its detail. Then at a certain distance threshold it will subdivide into 4 smaller equal patches. This is then repeated recursively for every patch, building a Quadtree node graph where every patch has 4 children. Right now this is all fairly naive and it's driven by the closest point on the sphere to the camera's position. As you can see, you can get quite close. As we look around, the horizon of the sphere looks suitably flat, so we've got close enough to lose the curvature of the sphere. There's actually no limit set on how far down this algorithm will tessellate. It's an infinite level of detail. It will keep going as long as floating point accuracy and memory permits. If I freeze the algorithm then, and we zoom out, you can see just how small those patches were we were just on, until we get to see the curvature of the planet again. That's a lot of patches. Not very performance friendly in the long term. There's no culling there at the moment, and that's the next stage. So this is the first pass at culling, only drawing those patches we can actually see inside the camera's frustum. As we get closer, fewer and fewer patches are drawn compared to the previous pass. And I apologise for the mental colour flickering here. Each patch is being given the next colour in the list when it's rendered, and now the number is changing whenever the camera moves as each patches are getting called. So as we get down close, and then I'll freeze the algorithm again and we'll zoom out, and then you can see the difference. So now none of the patches that were behind the camera are visible, but as you can see there's still way too many patches being drawn. Ones over the horizon that can't be seen when you're close to the surface need to be called as well. Okay, so this next pass is horizon culling. So again we'll zoom in. Get close enough to see quite a few patches. If we freeze it and zoom out, there's far fewer patches than previously. However, there's still too many, but right now that's good enough to start working on the planet proper. The main consideration here is every patch that's going to end up being rendered will need height deformation applying to it. So if that's done by a procedural mechanism like Perlin noise, every single vertex has to be height modified. So the more vertices there are, the more work to do, and if you can't see them, there's no point. Okay, here we have all 6 sides of our cube, all projected as a sphere and all dynamically lodding as we fly around. I hope no one has photosensitive epilepsy here. I'm used to this crazy colour flicker now, but my apologies if you're not. So now we can basically fly around our planet and have each patch dynamically adjust its size and spacing to suit, ready for us to be able to apply the height map. And bringing in the extra patches shows us another tech issue we have to fix. The new sides of the cube that have come in are being caught by the visibility testing, but we don't want them to. Even though they are correctly at the lowest level of detail, they wouldn't actually be visible from where the observer was on the surface of the planet. Okay, so now those patches have been culled, so now we're only going to be able to see pretty much what you should see with a few extra patches that will need to be called out. There's still too many patches being rendered there, so there's a bit more work to do, but the overall triangle count's not concerning at the minute, but it's an optimization for down the road. Aha! This is what's known as a bug. Those patches shouldn't be there at all. Right, to wind this up then, I probably should have put these stats in at the start, would have helped me during development, but there you go. And this is the non-technicolor renderer, you'll be glad to see. On the left there we have some stats on the geometry being rendered. Order shift is the minimum number of cells square in a patch, and the maximum, which I can increase and decrease. Radius and circumference of the planet there is set for Earth at the minute, so that's 6,000 kilometers in radius. And presently we're 15,500 clicks above the surface. Each patch at the moment is 1,600 kilometers square, with each pixel, sorry, couldn't think of a better term, is 265 kilometers square at the moment. These will shrink as we get closer to the surface, so let's take a closer look. If we zoom into about 1 kilometer, if I can get accurate enough with the flight. There we go. So each patch here about a kilometer is 100 meters across, which gives the pixel of about 10 meters. And we're roughly going between 6,000 and 30,000 triangles to render the scene at the moment. Which we can increase and decrease as we need based on the height map accuracy and so on, the level of detail. If we get down to 300 meters, the pixels get very small and we end up getting clipping the way the camera's set up at the moment. If we get it a bit closer in, So they're about 0.5 meters across each pixel at that level. So all in all, that's a good day's dev. The next task is to get some height information into the rendering, so it starts looking like a planet instead of a billiard ball. I appreciate it's been fairly dull to watch a sphere being tessellated, but this is all nice work in progress. As ever, thanks for watching.